All right, our second speaker in this session should be no stranger to most of you. Steve Watts from Genesis Crop Systems is going to talk to us about some research he's doing under the ACS Living Labs on foliar nitrogen fixation projects. Steve's been an independent agronomist since 2012, working with individual producers here in PEI, as well as initiatives like Living Labs, initiatives like our AIM program at the board, and with some additional partners, Dalhousie, Department of Agriculture, lots of people in the research and agronomy space here at PEI. So welcome, Steve, and we look forward to hearing more about foliar nitrogen products.
Thanks, Ryan. Good afternoon, everybody. So as Ryan mentioned, he asked me to come in. We've started a little bit of a research project here a couple of years ago, looking at some new products that might be helpful in improving yields in the potato farm, perhaps reducing costs, perhaps a little better in the environmental side. Who knows? Maybe there's several different opportunities here. So what I want to talk about today, I guess, very brief review of nitrogen-fixing bacteria science, our experience as Genesis and our research partners on potatoes here. Touch base a little bit on what's happening in some other areas, and then questions. Hopefully we'll have time at the end of it. Just before I start this, though, I've been doing a lot of nitrogen work in the last 10, 12 years on potatoes. We're not aiming at the basement here, okay? What we're trying to identify is ways that we can use nitrogen in a more smart fashion, more economical, without any negative impact on yield, quality, and profitability, and at the same time trying to address some environmental impacts that are associated with nitrogen fertilization. You look at the graph behind me there. It's pretty simple. It's from Idaho, long ways away from here, but potatoes pick up nitrogen the same here as they do in Idaho. And all I want to point out with that picture is that the potato plant, as do most other plants you grow on your farm, do not need all their nitrogen up front, okay, at planting. And they tend to feed on it more heavily, say, anywhere from 3 to 6 weeks after planting is when they really have the big demand. But yet we continue to apply most of our nitrogen up front here in most cases, and in many cases without any type of protection, whether that's dual inhibitors or polymer coats or whatever. So when you apply these products up front, there's a great opportunity to have some leakage out of the system, and more often than not, excuse me, that leakage becomes pollution. So in the case of legumes, this is kind of a snapshot describing how rhizobium bacteria work. Basically, you treat the seed of leguminous type crops. The rhizobium will form nodules on the root system. What happens there, you have a symbiotic relationship where the plant root exudates feed the rhizobium, and the rhizobium help the plant capture nitrogen out of the atmosphere. The first rhizobium was isolated back in the 1800s. As I said, it's specific to legume plants. There's over 90 different species identified of rhizobia, and they transfer atmospheric N. Depending on the crop, and we're doing lots of work on various legume rotation crops and stuff and trying to pinpoint how much nitrogen might be up for grabs. Depending on the crop, can produce 100 or more pounds per acre per year of nitrogen, right? So it's a big number. Forage legumes are normally higher producers or contributors than grain legumes, so crops like alfalfa especially, a number of the clovers and such, will generally fix more nitrogen than will crops like soybeans or white beans, etc. And alfalfa is one of the top dogs out here. It's easy to tell with rhizobium whether you made it work or not. You pull up a plant and you've got nice healthy white nodules on the roots. Guess what? You've got active bacteria there that are doing what they're supposed to do. A couple of recent offerings into the agriculture world here in PEI and elsewhere in numerous parts of the world are Invita and Nutritia. If you read the labels on those, these are basically the statements that are made. Invita is a liquid nitrogen fixing bacteria. The genus and species is there. It enables a unique mode of nitrogen fixation for a wide variety of crops. Nutritia is a different species. They call it a biostimulant. it's utilizing natural bacteria to capture and supply to plants when they need it most, okay? So this is right off their websites. I got it the other day. Both products at the present time recommend that users apply them to what they consider their normal nitrogen rates, or what I call their grower standard nitrogen rates, okay? There's a bunch of other products making claims too, and as time goes on, we're going to be introduced to more and more of those, I think. So I'll tell you, when I heard about this technology, as somebody that's worked in nitrogen and potatoes for a lot of years, I was pretty excited to get it in the field and see what would happen. So I'll wind the clock back to the year 2022. I call this year one. I approached both Exotic, which at the time was Invita, it's now sold by Syngenta, and Corteva, about doing some field trials here in PEI. Our basic hypothesis when we started is, can we introduce these one or both of these products in this case we worked on Nutritia. Can we introduce it into a potato field, commercial potatoes? Let's try for year one of reducing our applied mineral nitrogen by 15%, put on a spray of Nutritia when the time dictates, and see what happens, okay? So we had 5 sites across the island. There's 2 treatments per site, the GSP and the GSP plus minus 15% plus Nutritia. We applied the product alone as per company and label instructions at the time. Just about full row closure in the crop, okay? So the crop's still continuing to pick up a lot of nitrogen at that time. We pulled 4 10-foot strips from each side in each field, took them back to the warehouse and graded them for yield and quality. So there's the results we saw in year one. For the most part, looked pretty good. Equal or better numbers. There's no stats on these. We weren't looking for stats at the time. We're looking for trends. Equal or better 4 of the 5 times, close on the 5th. I just want to point out, though, yeah, this field over here accounted for the biggest part of that increase when you look at the average. And on the average of the 5 sites, we had 3,400 weight per acre. Even if we pull that extreme one, I'll call it on the left out, we still had a kind of a nice response going, I thought. The question is, and I guess we should have thought of it at the time, but we didn't, could we have just reduced the N by 15% and left that as was, what would have happened to our yield and quality in that case? Anyway, forest site and back site are both wonderful things, and sometimes they don't always line up with what you're doing. Ryan mentioned Ag Climate Solutions. So Living Labs is version 1 of a program funded by Agriculture and Agri-Food Canada. It's morphed to become Agriculture Climate Solutions now for version 2, we'll call it. Many of you know we did some work in version 1 on nitrogen with slow release or controlled release Super U nitrogen, saw some pretty promising results. So we approached both Syngenta and Corteva and said, looking to put in a project together, created a project team including Dave Burton from Dalhousie, Kyra Stiles and the squad from the Department of Agriculture, Judith and colleagues from Ag Canada, and some others. East Prince Environment kind of coordinates the ACS trials here, so they were a part of it. And then a number of PEI farmers that were engaged enough to help us with the trials and host the trials in their farm. The question was, can we use this product and reduce nitrogen rates? And when we do this, can we maintain and even increase profitability on the farm, okay? And what's it going to do to the environmental impact associated with putting nitrogen on potatoes? So we ended up with a 4-year project. We had 3 sites of each product per year for 4 years. We had a low and a high N rate for our base nitrogen. Remember I said I wanted to see if we could reduce N and what would happen? Or I guess the reverse hypothesis is, if these products are working, in theory we should be able to reduce our nitrogen, right? So we put in a super low rate. I'll talk about that in a sec. And we put it into gear, and we applied the products the same as I said we applied Nutritia. So we waited till almost full row closure, and the farmer would go in and put either Nutritia or Invita on their field. So large split field, there's 2 base N rates, like I said, 50 pounds. For the purpose of this trial, we called 150 our GSP rate. I know there's a lot of guys in the room putting a lot more than 150 on as their GSP rate. The fact of the matter is we've done trial upon trial upon trial, and we can't see response above that, so it became our default number. And then we added either Invita or Utrisha to the field over both of those N rates, okay? So we ended up with four treatments in each of the fields. Low N plus, GSPN, GSPN plus. We did our harvest, got our samples out, graded them for yield, quality, et cetera, and put the numbers up on the wall. Why the 50-pound rate, okay? I mentioned earlier we've been doing lots of nitrogen trials, and trials leading up to this, multi-year trials with Burton, and we would get down to 100 pounds of N, and I know nobody in the room's putting 100 pounds of N on their potatoes most of the time, and wouldn't certainly do it for their crop, but we weren't getting significant reductions in yield when we did that. So we said, okay, let's pull the trigger on this, and we went down to 50. Interestingly enough, we saw it in the field this time. I see very few nitrogen-stressed crops in PEI as I drive around. I do a lot of driving. But we got to see it here. There's a field of Payette russets, August 21st of last year. It was harder to get this picture from 12 months before that, though, with their trials, okay? So we had to do this on purpose, get down to this rate to really see what would happen what would it do to the bacteria. And I know researchers aren't supposed to have expectations when they do trials. I've heard that numerous times. It's nice to have a little expectation, okay? So when I was thinking, okay, how could this work? We'll look at these two lower nitrogen rates on the bottom. Theoretically, when you go up to the GSP N rates on the top, on the right, we should get a yield response, right? And then hopefully if the bacteria, if everything's working right, in either of these cases we add it on. We're really expecting one on the low N rate. Whether we get it on the high N rate, I guess, depends a lot on what's going on in the field. So here's our data from year one, from 2023, and everybody knows PEI had an exceptional year in 2023. We had rainfall galore. I don't think there's too many pounds of nitrogen left in the soil. I think it all mineralized and came available. We did see statistical differences in the yields in the sites that are mentioned there, but interestingly enough, they weren't as all as one would expect. For example, site 1, we got the same marketable yield with 50 pounds of N by itself as we did with 150 pounds plus the bacteria. And then the other two treatments were similar, but they were both higher than either, right? But not significant. Site N2 there was kind of creeping up the right way, and then it fell off when we got to the higher N rate. But Site 4 performed kind of like we had anticipated what we should see. And then Site 6, The funky thing was, though, here, most of these, we didn't see any difference. We went down to 50 pounds of nitrogen, which leads me to my next slide. Everybody read that closely, because the more we work on this stuff, the crazier some of the numbers get. So, what did we learn in 2024? A little more reflective of a normal growing year. We're fast out of the hole, but then in many areas went dry. Interestingly enough, we saw a number of sites where it behaved kind of like we thought it might. And we had statistical yield improvements at several of the sites. So I say the 24 data may be somewhat more like we'd expect, okay? But both of the companies, Syngenta and Corteva, said, you don't reduce your nitrogen with these products. You put them on top of whatever your grower standard practice nitrogen rate is to start, okay? And that's how they positioned them, okay? So we did a little bit of extra work there. And by the way, these graphs are also off the company's websites. I just peeled them off here over the weekend. Here's some numbers I did on Invita only when we added it to the grower standard practice nitrogen rate. And in some cases we saw numerical improvements in yield, in some cases we didn't. We averaged it all out. We had an average increase of 10 out of 10 hundredweight per acre, but it was only at 3 out of 7 sites we looked at, okay? And when I make my graph look like the other two graphs I just showed you, where we're showing the difference from 0 up or 0 down, ours are kind of more or less floating in the middle versus high trend towards yield improvement on the right-hand side of the graph. Excuse me. Is there a difference between the two products? We only have one site on this from 2023. Numerically, it's 18 bags the acre. I'd say for discussion purposes, just consider them equal. We could have two and could have seen the opposite thing. So if anybody asks me right now we'll consider both products equal unless somebody gets an awful pile of data comparing the two of them. On the environmental side, those red bars ingrained into the yields are what's going on with greenhouse gas emissions, and they're about as variable as the yield numbers are, right? In most cases, some cases they're, you'd expect as you went from 50 to 150N, your gas emissions are going to go up. We really don't know what's going to happen when we put bacteria into play in either of those nitrogen rates because nobody's really done any amount of work on it. But the numbers, like I say, consistency is not a key word in what I'm talking about for the most part here today, other than the way we set up the trials and kept score. So what are others saying? I just wanted to reach out. If you want a naysayer report on these products, for instance, from out Julie's way, he did a lit review, multi-years, multi-crops, not very much on potatoes that I could extract. And this is kind of his bottom line at the end of the day. Summary of results for most states, and if you look at the columns here, a no means there was no response in yield, a yes means there was. You keep going across here, you're looking at a lot more no's than you are yes. Is this valid to where we farm? Got no idea. Nobody's done the base work to say yes or no. This is just from one area. His recommendation's the same as mine as I get to the end. Try them on strips in your farm and get an independent agronomist to keep score for you. Okay, that's what you do with this stuff. It's not expensive. The University of Wisconsin also did some stuff. Excuse me, bunch of crops. Once again, this was a lit review, so if we look at here again, the no responses versus the A's, there's a lot more in the no columns than there is in the A's. This is Canola Research Hub. Once again, do they provide an economic benefit? When data, this is in Vita only too. When they combined all the data they had, they're not seeing any significant yield on canola yield for the most part. And not too much on the quality side of canola seed either. So summarize, I guess, we can't, there's not two T's in can't either, but anyway, we can't get consistent results. Why? Why can't we? When we see some of the other data that's put in place in front of us, is it the variety? Is it the environment? Is it other? We really need, and I talked with both Eric and Dustin here last week in New Brunswick, but we really need a good test to find out if we've got colonization or not, okay? Like I said, with rhizobium, you dig up a plant, you look at the roots, if you have nice healthy nodules, you got colonization, the bacteria are working. We've got no idea what's going on. You spray this stuff on the foliage of a crop, whether it's potatoes or wheat or barley or corn or whatever, so we don't know. Something in the back of my head, though, because I've been working on some high carbohydrate products in the last couple of years, what happens if we put some nurse food in the jug or in the program with this where we actually feed the bacteria for a short period of time until it does jump into the plant and take its own spot over, okay? So that's a question we have, and once again, we're having discussions with both companies here in the next few weeks, and we'll see what they think. We still have 2 years of ACS trials to complete, and I say the conclusions have yet to be concluded, okay? If a grower asks me what I think, I say, well, try a strip or two and let's do some tests and see what happens. I'm not going to say yay or nay, but make sure you do it with an independent scorekeeper. And I would like to figure this out. You know, my whole philosophy on nitrogen and stuff is try to keep finding better ways to do things. This makes sense if it can make sense, and we need to figure it out, I think, at least put some more energy in it than we have up to this point in time. I think it can help with producer costs, and it should be able to help with the environment when we get it straightened out. So I don't know where we're at for time, Ryan, but that's all the slides I threw together, and any questions, I'll try to address them.
Any questions for Steve? We have time for some questions if anybody's got any.
All good?
Daryl?
When the products were applied, were they tank mixed with anything or just?
No, for the purpose of this work, we kept them by themselves. Just, we don't have a lot of tank mix information, so to keep it simple. And these are, for the most part, we got enough product to do 10 acres, so instead of monkeying around measuring tanks, we just, when the farmer was done spraying for the week, put 10 gallons worth of water on, mix this in appropriately, and go put it on the strips.
Any other questions? Going once? All right, thanks, Steve.
Okay.